Hi, welcome to AB Video 2.1b, the alternative form of the limit definition of derivatives.
This one. So if you remember, the first one we saw was that f prime of x was equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. And remember, it's just a slope. It's the slope between the point x f of x and x plus delta x comma f of x plus delta x. So that's y2 minus y1, and then when you take x2 minus x1, you'll just get the delta x. Now that's a general formula that we can use to find the first derivative at any point x comma f of x. Now this original form can also be used, and we saw this before, to find the derivative at a specific point, a specific x value. So here the only difference is that instead of x, I have x1. So instead of x here, I have x1. Instead of x, I have x1. Now what we're going to do to get to this next alternative form is I'm going to do the following. Come over here to this little black cloud. So I'm going to say, you know what, let's just let x equal this x1 plus delta x. If I do that, then delta x, if I isolate it, will be x minus x1. And then when it says over here as delta x goes to 0, well, if delta x is x minus x1, that would mean as delta x goes to 0, then x minus x1 would go to 0, which means I could send that to the other side, and therefore x would go to delta x. So this is going to allow us to create something called the alternative form. The alternative form is the following. So remember, we used to have as delta x goes to 0, but we just showed that that's the same thing as letting x go to delta x. We used to have f of x plus delta x, but remember, we said let's let x1 plus delta x equal x, so this becomes f of x minus our f of x1, which it always was. That's the formula at a particular number. And I do want to emphasize something here. You can only use this alternative form to find the derivative at a specific point. So here I'm not changing the f of x1, and then in the denominator I'm replacing delta x by what it's equal to, which is x minus x1. This formula, in my opinion, is a lot easier to memorize if you think of it this way, which is it's the limit as x approaches x1 of f of x minus f of x1 over x minus x1. You'll notice it's x, x1, x, x1, x, x1. I think that's very simple. And then, of course, if you want to look at that graphically, instead of calling the points x, f of x, and x plus delta x, comma, f of x plus delta x, we purposely call point P x1, f of x1, and we call point Q x, f of x. And you can see that this is your x1, this is your x. If you let x get closer and closer and closer to x1, it's equivalent to delta x going to 0. And again, this is basically the slope, which is y2 minus y1 over x2 minus x1. And there is your y2 minus y1 over x2 minus x1. I have no idea why that shows up all the time. Okay, so in exercises 73 to 82, they're going to be very specific, and I will do this on the test. Use the alternative form of the derivative, which means the limit definition of the derivative, but the alternative form, to find the derivative at x equals c, and then they're going to have to give you a specific value. Okay, so number 74 is g of x equals x times x minus 1, which of course is x squared minus x. And the question is to find, therefore, the derivative of this function g of x at 1. In other words, find g prime of 1. So g prime of x1 is equal to, and there's our x, x1, x, x1, x, x1. The only difference is that it's a function g instead of a function f. So our x1, remember, is our c, which they told us was 1. So I go through and I replace all the x1s by 1. And therefore, remember our g of x was x squared minus x, so our g of 1 is 1 squared minus x. Don't forget the parentheses. That'll be important because you'll need to distribute that negative. And then when you simplify the top, you'll have x squared minus x minus 1 plus 1, which is 0, over x minus 1. If you plug in x equals 1, you'll get 0 over 0. If you then just factor the common factor out of the top, the x minus 1s will cancel, and all you're left with is the limit as x approaches 1 of x. Replace x by 1, and there's your answer. Okay, numbers 55 through 56, it says the given limit represents f prime as c for a function f and a number c. Find f and c. What they're asking you to do here is to recognize this backwards. So they're giving you this, and they're asking you to recognize it as that. Okay, whoops. I need to throw in a x1 right here. Let's see if I can do this. Okay, very thick. We don't know why. Okay, so you're going to look at this expression and you're going to go, okay, well, obviously x1, which is here and here, has got to be 9, okay, by pure substitution. And then your f of x is the first term of your numerator, and that f of x is 2 root x. And that's all they want you to do, is identify that the function is 2 root x and that the value of c is actually 9. Okay? And then you can just check it out, and sure enough, the 6 is f of 9, just like it's supposed to be according to the formula. Over here, this is supposed to be f of x1. And I don't know why this says f of x equals c. F of x equals 2 root x. And this should be c, well, it's x1. Oh, that's what's happening, because c is x1. So really I need to say that this is c equals x1, which is 9. Okay? And I don't think I have anything else down there.
And that's the end of video 2.1b.